Hey everybody, and welcome to McCardle Math Academy. This is another example using integration by substitution. So the example we're going to do here is a definite integral. The definite integral from 0 to 4 of sine of square root of x divided by square root of x. And here for our substitution, we're going to set w to be the square root of x. And the reason we choose this is that we notice that the square root of x is this inside function here. So our hope is that by making this substitution, we'll be able to cancel the square root of x that appears in the denominator of our integrand. And we're going to see if this actually works for us as we move forward with the substitution. So once we set w to square root of x, let's just rewrite that so we can work with it a little more easily. So that's x to the 1/2. We take a derivative of this w with respect to x, so we get 1/2 x to the minus 1/2. And then we're going to rewrite this to make it a little easier to work with. That's 1/2 square root of x. And now solving this little equation that we have here, dw dx is 1/2 root x. We want to solve that for dx. And when you do that, you'll find that that's equal to 2 square root of x dw. So in this box here is all the work that we needed for our substitution, and the important pieces are that w is root x and dx, let me get my blue here, dx is 2 root x dw. So we make those substitutions up above here, so we end up with sine of w divided by root x times 2 root x dw. So the w substitution was made here, and the dx substitution was made here. We notice that that cancels the root x's, and we're left with 2 times the integral of sine of w, all with respect to w. And the question might be, okay, well, what happened to the bounds of our definite integral? Once we make the substitution, the 0 to 4 no longer apply for our w variable. So what we do is we just add in these little asterisks for our limits so that we know that in the end we have to go back to x's before we can evaluate the integral in the end. So we apply basic rules here. We get minus 2 cosine w, and we evaluate it from some unknown value to some unknown value. We go back to x's, and now we can say that we go from 0 to 4. And then finally, this is the last step. We're going to apply the fundamental theorem of calculus, which says we input the 4 first, so we get minus 2 cosine of square root of 4, which is 2. And then we subtract a negative 2 cosine of the square root of 0, which is 0. And we just simplify this. We want to clean this up a little bit. Minus 2 cosine of 2. I don't expect you to know what cosine of 2 is, so we're going to leave it. And then cosine of 0, we all know that to be 1. So you end up with plus 2 on this side here. So this would be your final answer, minus 2 cosine 2 plus 2 in this case. Let me zoom out so we can see the whole picture. And that would be the answer to our definite integral. If you want to check, the best way to check something like this is just to make sure that the antiderivative we found here is appropriate for the function that we started with. And the way to do that is to take a derivative of this and make sure you end up with this function. All right, it's very hard to check a definite integral, but you can at least check the integral part of it. All right, hopefully this helps, and I'll see you guys next time.